All right, welcome back. Chapter 2, Part 1, I guess we'll call it Part 1. Now, in this chapter, we're going to be using descriptive statistics. Some of them are going to be, one of the things we're focusing on is tabular and graphical displays. We'll be using this for both categorical variables, such as eye color, rankings, ordinal data, right? Remember that, nominal and ordinal data. And we'll be using them to summarize quantitative data using a quantitative variable. Quantitative variables or data are numerical values that indicate how much or how many. Categorical data are labels or names used to identify categories of like terms. So you'll remember that from chapter 1. We're going to be looking at a frequency distribution. That's a count. A frequency is how many times something occurs. If you ever listen to FM radio, the different channels on the dial deal with the relative frequency, how many waves there are per foot or whatever. Relative frequency distribution, that is a decimal. Let's say 10%. We had 50 data items. 2 of them were in, say, a poor category. We take 2 divided by 50. That would be 0.1. Okay, is that right? 2 divided by 50. Okay, 0.4, 0.04. So 4%, and that would be a percentage. Okay, we'll show how to do all this: bar chart, pie chart. A frequency distribution is a tabular summary of data showing the number of frequency or number of observations. The frequency is the number of observations in each of several non-overlapping categories or classes. The objective is to provide insights about the data that cannot be quickly obtained by looking only at the original data. So what we're doing here is we're taking, say, a big sheet of data with 50 observations, 500, it doesn't matter. To sit there, look at that, you're not going to get much out of it. It's going to take you a long time to read it. What we're doing is we're summarizing that with a table or later on a graph so that you can quickly get the information that you need from the data set. Right here, this is a frequency we're going to be using. We're going to be doing a frequency distribution on data from Narrated Inn. They asked their guest, were your quality of your accommodations excellent, above average, average, below average, or poor? We sampled 20 guests. These are their responses. Okay. Then we're going to put this into a frequency distribution first. The frequency is the number of times this class shows up in our survey. So we go back to our survey. Poor was a response by only 2 of the 20 guests. So we put a 2 here for frequency. 2 people answered poor. Below average, going back, there were 3 below average responses. The frequency, the number of observations we have had where people said their room was below average, was 3. Average 5, above average 9, excellent 1. You could go back and look at that and tabulate those things. Now, we add up the frequencies to make sure that we've got all 20 of our observations in our frequency distribution. We sampled 20 guests. We have 20 answers. We're looking pretty good at this point. The next thing we're going to look at is relative frequency distribution. This is a decimal. You take the frequency of the class. So for poor, the frequency of that class was 2. And you divide it by the number of observations in this sample. In this case, 20 observations. We asked 20 people. 2 of those 20 people responded poor. A relative frequency distribution is a tabular summary of the data showing the relative frequency of each class. So we do this calculation for each class and we record it. 2 divided by 20 is 0.1. We also can show a percent frequency distribution. Here, the percent frequency of a class is the relative frequency 0.1 times 100, or 100% really. So here, a relative frequency of 0.1 times 100 is 10%. 10% of the respondents said the room was poor. Here, our relative frequency was 0.15. We multiply that by 100%. 15% of the responses were below average, so forth and so on. The next thing we're going to look at is a bar chart. We can graph the frequency distribution. Going back here, we can graph the relative frequency, going to this part of the second table, or the percent frequency in a bar chart. We use a bar of fixed width drawn above each class. We extend the height appropriately. The bars are separated to emphasize the fact that each class is a separate category. Now, whenever you draw a graph, the first thing you have to remember is, why am I doing this? We don't normally draw graphs for ourselves. Instead, we draw these graphs to convey information to other people. So when we draw the graph, we have to make sure we draw it in a manner that other people who know little to nothing about what we're talking about can understand the graph. There are certain procedures you want to go through when you draw a graph so that other people will understand it. The first one is missing from this graph, and that is right here where the x and the y-axis cross. The x is the horizontal, the y is the vertical axis. We want to put a 0 right here. That says that's the origin. That's where both the x variable and the y variable are both 0, right there at the corner. Then you want to label your axes. In this case, we're graphing a frequency distribution on a bar chart. So we're going to put frequency here. That's the number of times a guest responded poor, below average, average, above average, or excellent in the 20 people we surveyed. On the x-axis here, we have quality rating. Okay, quality rating. Then we mark off our units. When we're using mathematical or numerical units, we want to make sure that these numbers are evenly spaced. There's no difference between the distance between 0 and 1, 1 and 2, 2 and 3, etc., 7 and 8, 9 and 10. There are instances where we have parts of a chart where there's a big part that's not interesting or useful to us. We can demonstrate that by making a break, 2 lines with a space in between them going across the axis, saying, hey, we broke this part of the chart off. It's not interesting. Here's what's interesting for you. For quality rating, we marked off our units. Those were poor, below average, average, above average, and excellent. Then we took a line starting from poor, went up to 2. That was the number or the frequency we had for poor responses on our survey. Draw a line, go over. You want to make sure when you're doing a bar chart, unlike a histogram, that you leave space in between the bars. Below average, we had 3 responses. The frequency was 3. We draw a line up to 3, go across and go down. Again, leaving space in between the bars. 5, 9, 1. Then the most important thing was we put a title up here. What if we didn't have this title here? What would we be looking at? We wouldn't know. Here, we know we're looking at Narrated in quality ratings. I can look down here at poor, and I say, oh, the frequency was 2. 2 people rated the quality of their rooms poor. A Pareto diagram is a bar chart, basically, where we arrange the classes according to height from left to right. The most frequently occurring response comes first, then additional responses as in a descending order according to their frequency. A Pareto diagram is very useful because we can use that, for example, in quality control. We can look at, say, these rooms, and we can ask those customers, what, if anything, was wrong with your room? Some customers might respond, there were no towels. That might be the biggest problem we have with the quality of our rooms, is that the maids aren't putting enough towels in the room. We can address the most important issues because they have the highest frequency of being complained about first, and improve those quality ratings by addressing the most important needs first. The next thing we're going to look at is a pie chart. Now, we're not going to be drawing very many pie charts by hand in this class because it's online and a lot of stuff is turned in electronically, so we will be using Excel. If you look at the bottom of the course content folder, there are Excel videos that will tell you how to do various things in the course. One of them is draw a pie chart. But a pie chart is a commonly used graphical display for presenting relative frequency and percent frequency distributions for categorical data. First thing you do is draw a circle. Then use the relative frequencies. Remember, those are the decimals we used here. 2 responses poor divided by the total of 20. 2 divided by 20 is 0.1. You take the relative frequency and you multiply it by 360 degrees when you use a pie chart. That will tell you how many degrees you need to draw that particular slice of the pie from the last slice you drew. So here, we're starting off here. That's 0 degrees. We had, going back here, a 0.1 relative frequency. We multiply that by 360 degrees. So we start here at 0, go over, say on a protractor, 360 degrees. That becomes our first slice. The next slice would be 0.15 times 360. That comes out to 54 degrees. So we would start here and go 54 degrees in a clockwise fashion. Draw another line to indicate this slice, color it in, it becomes below average. But we'll be doing most of these on Excel. People very rarely draw them by hand anymore. And looking here, they say half of the people gave them a above average or excellent. So the manager might be happy with that. He might not. Okay. When we summarize quantitative data, remember this is quantitative. It's indicated by a number. This could be, say, the prices of parts, again at Hudson Auto. We'll use frequency distribution, relative frequency and percent frequency distributions, dot plots, histograms, cumulative distributions, and stem and leaf displays. A frequency distribution is very similar to what we did before, except here we're going to use the cost of the parts rounded to the nearest dollar here on this slide, and we're going to create classes for those. The lowest number is 52, the highest is 109. So we're going to create classes. The first class is going to start at below $52. The last class will end at or above 109. And then we'll create a frequency distribution. Time is up for this video. We'll start here on the second video when we get back. Thank you very much. Have a great day.